On September 23, 1999, NASA's Mars Climate Orbiter, after nearly a year-long journey across 400 million kilometers of space, was set to slip into Martian orbit. It was a groundbreaking new mission to study Mars's atmosphere and climate. But as the spacecraft descended, communication with it was suddenly lost. And just minutes later, NASA realized the worst-case scenario. The $327 million orbiter had been destroyed in the Martian atmosphere. In November 1999, the Mars Climate Orbiter Investigation Report released the cause. It was a simple and yet catastrophic mistake. NASA and its contractor, Lockheed Martin, had used different systems of measurement. NASA used the metric system, and Lockheed Martin used imperial units. A failure to properly convert between metric and imperial in the thruster calculations led the orbiter on a fatally low trajectory into the Martian atmosphere. NASA itself admitted that if proper tests and validation had been conducted, the mistake would have been caught in advance. If a multi-million-dollar mission led by NASA could be lost to something as simple as a unit mismatch, imagine the potential for untested errors in your own code. No one writes perfect code, which is why thorough testing is crucial for success. After years of development, a small oversight led to the loss of an entire spacecraft. The lesson here is that it's really important to test your code. Testing is a safety net that helps catch errors before they cause bigger problems. Let's talk a little about the different types of tests you can write. Projects often start with unit tests, which focus on small, isolated parts of your code, like individual functions or method. These tests ensure that each unit works as expected in isolation. For example, if you have a function that calculates the mean of a list of numbers, you could write a test to ensure that the function correctly calculates a mean. For example, by checking that it returns the value that you expect when given a predefined set of numbers. Then we have integration tests. Integration tests check how different components interact. They test how different modules or components of your application work together and make sure that the system functions as a whole. For example, you might have separate functions for data cleaning, data analysis, and visualization. An integration test could ensure that after your data is cleaned, the clean data correctly flows into your analysis function and produces the expected statistical results, like a t-test or linear regression. Finally, there are functional tests, which focus on how the software behaves in a real-world scenario. For example, a functional test could verify that a user interface for statistical analysis correctly lets users input data, run an analysis, and display results in a graph. It ensures that when users interact with your app, it behaves as expected. Let's walk through an example to show how testing can help you catch errors early and ensure that your code behaves as you expect it to. In Python, pytest and unit tests are the two most widely used testing libraries. Now, let's imagine you're an economist. You have survey data containing years of education, so how many years of schooling each person has completed, and income, so each person's annual income in US. What you're trying to do is clean the data, group it by the number of years of education, and then calculate the average income for each education. So we've got a function to clean the data by removing invalid values, a function to group the data by education level, and finally, a function to calculate the average income for each group. Now, let's write some quick unit tests using pytest to make sure that everything works like we expect it to. First, let's create a directory called test. The convention with code bases is often to put the source code in a directory called source, and then keep the tests in a directory called tests. We'll save the test code in a file named testpipeline.py. So we've got a test here to clean the data. We've got a test for grouping by education level, and we've got a test for calculating the average income. Now let's save the file and run the test with pytest. Hooray, we can see that it passed. Now let's show an example of an error that could be caught with these tests. Let's intentionally introduce an error in the group by education function. Right now, it groups data correctly by education level, but we'll introduce a mistake where it doesn't correctly handle cases where there's a missing education level. Here's the incorrect version of group by education. Now let's run pytest again to see the results after the error is introduced. The group by education test failed because the group data dictionary no longer contains keys for education levels 12 and 10 after cleaning the data. The test tries to access those keys, but they don't exist anymore due to the error in the grouping logic. Now let's fix the code. And now that we fixed it, we'll rerun the tests. This time, everything will pass. You can also do cool things like run code coverage reports, which tell you what percentage of your code is actually tested. Now, I want to quickly talk about mocking. When testing your code, sometimes you don't want to interact with real external systems like APIs or databases or web services. This is where mocking comes in. Mocking lets you simulate these external dependencies so you can test your code without actually making network calls or database queries. It's useful when you want to isolate and test very specific parts of your code without waiting for real data or risking unwanted side effects. So let's say you have a function that fetches data from an API, but you don't want to actually make that API call every time you test it. Instead, you can mock the API response. Here's a simple example using unittest.mock in Python. In this example, instead of making an actual API call, we simulate the response by returning fake data when request.get is called. Now, I want to quickly put in a word about the philosophy of test-driven development, or TDD. Test-driven development is an approach to writing code where you write tests for the code before you write the actual code itself. This approach ensures that testing is built into the development process from the start and makes it very easy to catch errors early. It improves your code quality and it ensures that your code does exactly what it's supposed to do. TDD promotes writing cleaner, much more reliable code by keeping developers focused on small, manageable tasks while continuously validating their work through tests. So, with TDD, you have a safety net of tests that ensures your code still works as expected when you make changes. This is very valuable for data scientists who frequently refactor code or optimization or add new features. Without tests, refactoring can unintentionally break existing functionality, but with TDD, the test will immediately highlight any regressions and allow you to confidently improve your work without fear of hidden issues. So that's it for today. Thanks for watching. In the next video, we're going to talk about regular expressions, which are like a smart search tool for text. They help you find patterns in words, but in a way more powerful way than you can just do with search replace. If you learn new things that you didn't know before, give this video a like and don't forget to subscribe for more videos. See you in the next video.